Well, hello everybody. What I need to do with you today is I need to cover section 4-1 with you. There's a lot of information here in section 4-1, a lot of ratios that we'll be talking about, a lot of conversions that we'll be talking about. So the things that you need to have in front of you, you should have the class notes. They should say day 1 class. Number 1 should say negative 135 degrees. If you have that paper in front of you, we're going to be sitting pretty good. You'll also need a calculator today. Since it's a video, usually I'll click through the calculator part with you, but you need to make sure you know how to use your calculator. So if you need, pause the video, type that in, and then we'll go from there. So what I'd like to do first is, these are not on your notes, but I need to talk to you a little bit about circles. I'm going to throw some facts at you about some circles that you've seen back in your geometry days and prior. So here goes. Today we're going to be looking at circles. Remember, any circle has some radius. Radius is the distance from the center to any point on the circle. Some formulas that are going to show up today is you're going to need to know how to find the area of a circle, so pi r squared. You're also going to need to know how to find the circumference of a circle, or a partial circle. Remember, circumference is the perimeter of the circle, the distance around the circle, and that formula is 2 pi r. Today you're also going to see and hear, we're going to cut a piece of pi out of there, and I'm going to use the angle theta quite a bit. Theta is like x. It can represent any angle that I'd like to talk about. You're going to hear terms like, I'd like to find the area of a sector. Well, the area of a sector means I'm trying to find this area of that piece of pi. You might also hear today, we're going to find the arc length. Well, the arc length represents this distance right out there, the distance from there to there. So you're going to hear that a little bit today. Some other things that you're going to hear today is, notice I've got some concentric circles here. I need to talk to you about arc measure. And then I need to talk to you about arc length. Arc measure is the angle that's being used. So for instance, guys, if this is a 50-degree angle, if you look at that little circle, I would say it has an arc measure of 50 degrees from there to there. If you look at the second circle, the middle circle, I would say this has an arc length, arc measure of 50 degrees also. Notice that they're totally different circles, but the arc measure is the same. If you go out to that farther circle, it also has an arc measure of, you guessed it, 50 degrees. So arc measure just represents the angle that's being used to create that sector. Now, where it gets a little bit different though, is if I put you on a track and I ask you to run from there to there, you're running a shorter distance than that person going from here to here or from here to here. Notice the bigger the circle, the further the distance is. Well, that's where what arc length comes in at. Arc length represents that distance from there to there. You're going to hear today the word radian. You're going to hear that a lot. Here's where the radian measure comes from. If I pick on a unit circle, and when I say unit circle, that means it has a radius of 1. If I ask you to find me the circumference of that, you would tell me it's 2 pi r. I'm going to sub in 1 for the radius, so the circumference of a unit circle is 2 pi. You've heard that in geometry before. Now we're going to put units with it. It really represents 2 pi radians. We say radians, we don't write radians. But radians gives us a way to measure the distance from there to there, there to there, and there to there. And they're all going to be different. So I've got one more circle I want to talk to you about. I'm going to toss a lot of conversions at you real fast. That's going to come your way. These are just facts. This is going to be a unit circle again. You're going to hear the term today, revolution. Revolution means you're just going to go around this circle one time. So picture these and see if they make sense to you. In one revolution of a circle, there's a total of 360 degrees. Now, on any ratio, you could also flip them around. there's 360 degrees in one revolution. So there's one conversion that we're going to talk about a lot today. Here's the one we're going to use a lot. You can go one loop around the circle. That's 360 degrees. So the arc measure would be 360 degrees. Remember back on my previous slide, we found the circumference of this circle. It was 2 pi times 1. Well, one lap around this circle is 360 degrees, but that's equivalent to 2 pi radians. So another conversion you're going to hear a lot today is that 180 degrees and pi radians are the same thing. Once again, I can flip those around. Pi over 180 degrees. So there's a couple of conversions that we're going to hear quite a bit today. Now, I just want to pick on this circle a little bit more before I jump on your class examples. Right here I'm at 0 degrees. I'm also at 0 radians. If I go this loop around the circle and stop there, I'm at 180 degrees. I'm also at pi radians. If you take half of 3.14, that would represent the distance from there to there. And then, of course, from there, guys, I can break it down even more. 90 degrees and pi over 2 radians are the same thing. I could go 270 degrees and 1.5 pi's are equivalent. So the big thing I need you to know for now, know these conversions, and I'll show you how to use them. While I'm here, notice that I'm in degrees here. I could also add in that in one revolution, there's 2 pi radians, or there's 2 pi radians in one revolution. So there's where we are so far. Okay, so if you would, swing over to your first example there, and I'll click right through these guys. I've already got all the prep work done now. Going through the class examples shouldn't be too long. So here goes your number 1. It says the measure of a rotation is given. Here's what that part means. I have a radius, and traditionally we start right there. We're going to rotate that 135 degrees. Now notice that there's a negative in front of this. Well, if I go counterclockwise, I'm doing a positive direction. If I go clockwise, I'm doing a negative rotation. The negative just means the direction that we're going. So in this case, we're going negative 135 degrees. So picture where that would be. I'm going to go this direction. Well, here is 180. So 135 must be somewhere in there. So we're going to convert that negative 135, we're going to convert it to a measure of revolution. So here goes. To do this, I'm going to say there's 135 degrees. I need some ratio that works with degrees and revolutions. And when I do this, I need degrees on bottom. So I'm going to say in one revolution, there's 360 degrees. The reason I need the degrees on bottom now, notice that these cancel out. Now I'm going to grab my calculator, and I'm going to go negative 135 divided by 360. If it's an ugly number, I'm going to go math, enter, enter. And in this case, I'm going to get negative 3/8 of a revolution. So that's how we hit that. Here's your number 2, 7 pi halves. Picture it where we are. And then you can kind of keep track of my revolutions. I'm going to take this, and as I swing this around, there's 1 pi right there. When I get back to here, I'm at 2 pi. I need to get to 3.5. So I've done one loop so far to get back to there. When I go again, now I'm up to 3 pi, and I need to get to 3.5. So I need to be right in there. Math-wise, it's going to look like this. I'm going to have 7 pi halves. I'm going to multiply by some ratio that once again deals with revolutions and, in this case, radians. So I'm going to say in one revolution, there's 2 pi radians. I use degrees over here because we're in degrees. I use radians here because I'm in radians. Now the pi's cancel out, and I'm going to get 7/4 of a revolution, or you could call that 1.75 revolution. So guys, just be careful in what we're in. I'm in degrees, use 360. I'm in revolution, so I use 2 pi. My number 3 says give 2 other degree measures, one positive and one negative, for a rotation of 152 degrees. Well, what I'm doing on the circle is I'm rotating around to 152 degrees. Well, what this means is, are there other ways to get there? I call it doing extra laps. I would like to end up at 152 degrees. I'm going to stop there. Well, I'm going to add 360 degrees to that. 360 degrees just means you did an extra lap. So another positive one could be 512 degrees. Now I need a negative one. I'm going to go 152 degrees minus 360. Run that through your calculator. You're going to get negative 208 degrees. I could play that game forever. I could keep adding 360 and I could keep subtracting 360. Now in this case, I was in degrees, so notice I used degrees. Well, check out number 4. Give 2 other radian measures, one positive and one negative, for a rotation of 5 pi 6th. Well, all I'm going to do is I'm going to have 5/6 pi. I'm going to add 2 pi to that, and then I'm going to go 5/6 pi minus 2 pi. 2 pi represents one revolution. Now, you can do this in your head or your calculator. You would go 5/6 plus 2, math enter, enter, and you would get 17/6, and then just put your pi with it. So notice I did not type that pi into my calculator. Same thing on the next one. 5/6 minus 2, math enter, enter, you're going to get negative 7/6. Put that pi with it. And then we got it. Okay. So there's what we got so far. Here's your number 5. I'm going to switch colors on you here. We'd like to convert each degree measure to an exact radian measure. So I'm going to take 30 degrees. Now, I need some ratio that deals with degrees and radians. So what I'm going to do, and I need degrees to be on bottom. So I'm going to say in 180 degrees, there's pi radians. Now, the thetas cancel out, the degrees cancel out. I'm going to go 30 divided by 180, math enter, enter, and I get 1/6. So my answer is going to be pi 6th. Pi really represents 180 degrees. 180 divided by 6 does get me back to 30. 45 degrees is going to look like this. 45 degrees. I'm trying to turn it to radians. So I'm going to say that there's pi radians in 180 degrees. The degrees cancel out. 45 divided by 180, math enter, enter. I'm going to get pi force radians. Now remember, this is the distance that arc would be. We're in degrees, now we're in distance. Negative 240, I'm going to do the same thing. I need to get rid of the degrees, so I've got 180 down there. I've got pi up there. Cancel the degrees out. Run this through your calculator or your brain, and you're going to get negative 4/3 pi. So guys, to convert from degrees to radians, notice that degrees were on bottom, radians on top. Now I'm going to go the other way on number 8, 9, and 10. Convert each radian measure to a degree measure. So it's going to look like this. I've got 7/4 pi. I need to get this to a degree measure. So this time I need degrees on top, radians on bottom. So I'm going to say that there's 180 degrees in pi radians. The pi radians cancel out, leaving me 7/4 times 180. I can run that through my calculator and get 315 degrees. After you do a few of these guys, you'll notice some little shortcuts you can start taking. For today, I'm going to show you everything in terms of conversions and units. Here's negative 3 pi tenths. I'm trying to convert this to degrees, so I'm going to say that there's 180 degrees in pi radians. Those cancel out. We'll run that through our calculator, and I get negative 54 degrees. Remember, the negative just means you're going clockwise. So another way to say this would be 54 degrees clockwise. Both of these are correct. And then my number 10, I've got 4 pi. I'm trying to get to degrees. I'd like to get rid of those radians. 4 times 180 looks like 720 degrees. Make sure you get your degrees as your units on there. Now, what we did in class, guys, is I turned your classmates loose on number 11. So what I'll do here is I'll walk you through this first one. If you'd like to hit pause on the video and make sure you could get the other answers, you sure can. But your classmates did extremely well on them. So here's your number 1 here. I'm going to take negative 37 degrees, turn it to radians. So I'm going to do that over here. So I've got negative 37 degrees. I'm going to multiply by pi over 180. That way my degrees cancel out. 37 over 180 does not simplify. So exact radians is negative 37 over 180 pi. To get it to radians to the nearest tenth, you will just grab your calculator and go negative 37 divided by 180 times the value of pi, that 3.14 number, and you're going to get about negative 0.6. When we convert it to revolutions, I'm going to say negative 37 degrees times, there's 1 revolution in 360 degrees. Degrees cancel out. So I've got negative 37 3/60ths of a revolution. Notice the units again, guys. Degrees has degrees. Radians have nothing. Revolutions have revolutions. So I'm going to quickly write up what the other answers should be. If you would like to hit pause on the video and see if you get them, fine. If not, give me about 5 seconds and then we're going to move on. So guys, that's what the rest of the chart should look like if you want to pause and see if you're doing okay. If not, we're going to keep on keeping on. So come over to your number 12. Part of this is from your geometry. Nope, I'm going to change my mind. If you would, go to your number 14 first. Let's get the 2 easier ones out of the way first. And then when I do the 2 harder ones, they're going to make a little more sense. Now, when we do these problems, you have to decide right off the bat if we're dealing with area or if we're dealing with arc length. If we are dealing with area, you're going to use the formula pi r squared. If you're dealing with arc length, we're going to use 2 pi r. So here goes my number 14. It says consider a circle with a radius of 6. So I've got a circle, radius of 6 feet, and a central angle of 75 degrees. So about right there. On my number 14 here, it says find the exact length of the arc cut off by this angle. So we're trying to find this distance right here. So what I'd like for you to do is think about what the formula looks like first before we plug in any number. And our book likes to use S for arc length. You'd think they're going to use A, but they use A for area. So my arc length is going to look like this. It's going to be the angle that I'm working with out of 360, because I'm dealing in degrees, times 2 pi r. Well, now let's go run those numbers through. So I've got arc length is, I'm dealing with the 75-degree angle out of 360 times 2 times pi times 6. Now be careful. We want the exact length. So when you type this in your calculator, do not type the pi. Type 75 divided by 360 times 2 times 6. Hit your math, enter, enter if it's an ugly number. But in this case, guys, you're going to get 2.5, add your pi with it. And in this case, my units happen to be feet. Now, when we hit number 15, notice that it says find the exact area. Find the exact area. So think through your formula before we even start. The area of this arc is going to be the angle that I'm working with out of 360, since I'm in degrees, times pi r squared. Now let's go grab your numbers. The area of this arc is going to be 75 over 360 times pi times 6 squared. Once again, type everything through your calculator except for the pi. If you go 75 divided by 360 times 6 squared, you're going to get 7.5. Put your pi with it, that way it's exact. Add your units of feet squared, and then we got it. Now, the reason I wanted to do number 14 and 15 first, number 12 and 13, they are in radian measure. So we're going to handle those the same way, but we're going to simplify our formula first if we can. Notice in this case, my radius is 5. My angle measure is in radians. It's 7/12 pi. So number 12 says, compute the exact area. So here's how we're going to attack this. I'm going to say the area of this arc is theta over, not 360 this time, because I'm in radians. So it's going to be theta over 2 pi times, we're doing area, pi r squared. Now we're going to simplify this formula first. If not, it's going to be too confusing for some. Notice that the pi's cancel out. I'm going to have a 1/2 left over. I'm going to have a theta, and I'm going to have an r squared. Now, let's go grab our stuff. I've got area equal 1/2. My theta is 7 pi 12ths. My radius is 5, and I need to square that. Once again, just like we did, since it says exact, type in 1/2 times 7/12 times 5 squared. Do not enter your pi value, so you're going to get an area to be 175 over 24. Put your pi with it, and in this case, it's going to be units squared. So guys, moral of that story, write down your formula, simplify it, plug in the numbers. Number 13 is the same thing. Compute the exact arc length of A to B. Well, so S for arc length. I've got theta over 2 pi, since I'm in radians, times 2 pi r. Now, this is a great example on why I want you to write the formula down first. Notice in this case, the 2 pi's cancel out of there. So your arc length is simply theta times your radius. Theta times your radius. So check this out now. The arc length is going to be 7/12 pi times 5. 7/12 times 5, 35/12. Put your pi with it. My units just happen to be units. So guys, arc length and arc area, area of a sector, just write down your formula, simplify it, and then plug in. Okay, if you would, bounce on over to your number 16. It's just using those two formulas again. And then I'm going to show you 18 and 19. Guys, we're about 10 minutes away from the video, maybe 8. So here goes. Number 16. If a sector in a circle with a central angle of 2/3 pi, one thing I know, guys, we are in radians, has an area of 25/3 pi, I also know I need to deal with the area formula. What's the exact length of the radius? So here we go again. We're dealing with area. So area is theta over 2 pi. Why 2 pi? We're in radians. Times pi r squared. Let's simplify this. So I'm going to have a 1/2. I'm going to have a theta and an r squared. Now let's plug in the numbers they give me. They tell me the central angle is 2/3 pi, and the area is 25/3 pi. So I'm going to go 25/3 pi equal 1/2. My angle is 2/3 pi, but I do not know the radius, so I've got r squared. Now, it looks really confusing at this moment, but let's simplify some things. Let's divide both sides by pi and get rid of those. So now I've got 25/3 equal, I'm going to take 1/2 times 2/3. These 2's are going to cancel out. So I've got 1/3 r squared. We don't like the fractions, so let's multiply both sides by 3. So I've got 25 equal r squared. Square root both sides, so my radius in this case must be 5 feet. So a little bit of algebra in there for you. Here's my number 17. If the arc of a circle has a radius of 5 and a length of 25/8 pi feet, find the measure of the angle in radians and degrees. In radians and degrees. Well, this is definitely an arc length question because it says the arc. So I've got S equal theta over 2 pi times 2 pi r. Simplify. The 2 pi's cancel, so I've got theta times the radius. So that's pretty sweet. So here goes. It says the arc length of a circle with a radius of 5 has 25/8 pi. So let's go 25/8 pi equal. We don't know what theta is, but we know the radius is 5. Let's divide both sides by 5 and go math enter. You could multiply both sides by 1/5. So I would have 25/40 pi, which would reduce to 5/8 pi. So there it is as a radian. To turn it to degrees, I'm going to go 5/8 radians. I'm going to say there's 180 degrees in pi radians. The pi's cancel out. 5/8 times 180 leaves me 112.5 degrees. So there's just 2 more applications of the formula real fast. Okay, 18 and 19 are going to be pretty easy for you. Just like our time system, if I talk about 1 hour, an equivalent to that would be 60 minutes. If I want to talk about 1 minute, we could say that there's also 60 seconds in a minute. Well, degrees can also be broken down just like that. In 1 degree, there's 60 minutes. If we wanted to go even more, which we don't on this lesson, but I could say in 1 minute, there's 60 degrees. So, kind of a little bit there. So, here goes. Let me show you how easy number 18 is. To convert 55 degrees, 32 minutes to degrees, it's going to be 55 point something. Well, to do that, here's all we do. I'm going to go 55 plus 32 60ths, because there's 60 minutes in 1 degree. If you run that through your calculator, you're going to get 55.5 with the 3 repeating. So there we go. It's 55.53 degrees, and the 3's repeating. If you just listed it with the 3, put it approximately in the front. My number 19, to convert that, I'm going to go 87 plus 44 over 60. Run that through your calculator. You're going to get 87.73 degrees. Once again, the 3 repeats. So it's just a way to break down our degree measure. My number 20 would be 13 plus 14 sixtieths. That came out to be 13.23 degrees. Okay. Now, I'm almost done. If you would, right before I hit number 21, I'm going to hit number 21, then I'm going to be all done. I need to talk with you just a little bit about longitude and latitudes. If you're looking at a globe, you got your longitude lines and you got your latitude lines. Notice that right through here represents our longitude lines, and our latitude lines are our vertical lines. They look vertical. Just, I took a snippet of the United States, and I wanted to see how close we could get to finding Hayes, America. Well, picture where Hayes, America is. It says it's at a longitude of 99.32 degrees. So I would need to come over to 99 degrees. So I'm going to start here. I'm going to come over to 99 degrees, 0.32. So I'm really close right there. And I would need to come up to 38.91 degrees north. So I'd need to come up to where I think 38.9 degrees would be. So maybe right in there. So there's Hayes, America. Now, these are kind of nice little problems. Here's your number 21. It says Grand Rapids, Michigan has a longitude of 85.67 degrees west and a latitude of 42.97 degrees north. Louisville, Kentucky has a longitude of 85.77 degrees west and 38.25 degrees north. Because their longitudes are very close, assume that Grand Rapids is directly north of Louisville. If the radius of the Earth is about 3,960 miles, estimate the air distance from Grand Rapids to Louisville. Well, guys, to hit these, here's how we do this. Notice that the longitudes are really, really close. 85.67 and 85.77. We're going to toss those. They're not going to throw our problem off very much. When we hit these problems, here's how we're going to attack this. I'm going to think about a grid here for you, where here's my North Pole, and here's the equator. Now picture what we're doing. It says Grand Rapids goes 42.97 degrees north. So I'm going to grab my radius of 3,960 miles, and I'm going to rotate that up to where I think 42.97 degrees is. And then right there stands Grand Rapids. Now, I'm going to do the same thing for Louisville. Louisville's at 38.25, so Louisville's going to be 38.25. Well, check out what we have now. I have this little arc right here that I'd like to figure out how far that is. Well, step number one, I need to figure out what the angle is that I'm working with. Well, to get the angle, I'm going to go 42.97 minus 38.25. So it looks like that angle is 4.72 degrees. So I know the angle that I'm working with is 4.72. I need to decide now, am I dealing with area or circumference? And since I'm looking for this distance right here, we're working with circumference. So I'm going to say theta over, and I'm in degrees, so 360, times 2 times pi times r. Now let's plug in those numbers. Theta over 360, and theta is 4.72, times 2 times pi times the radius of 3,960. Now we're just going to grab our calculator and run that through, and then see that word estimate? That means go ahead and plug in the pi value of 3.14. And if you run that through, guys, you should get about 326 miles. That went a little quicker than I wanted. So, hey, there's the lesson on Section 4.1. We're sorry that you missed class, or sorry that we weren't there, whichever is the case. You should also have the assignment to it. There's a staple in it, so don't be too scared. But it's a very important lesson, so make sure that you get to understand it. Come in and see Miss Dinahan or myself if you have any questions.